we're doing today is we are starting chapter 7. Chapter 7, first part of it is going over, and all this is going over, our rational equations, our fractional equations and expressions. Factoring is going to be a big part of it, especially if there's common factors on top and bottom. There's something that can be reduced, we need to reduce it. That's part of the reason we went back over factoring, because factoring will be a big key part of this here. But before we get to that, we're talking about direct and inverse variation. Now, direct variation compares two things, and they increase or decrease by a constant amount. If one increases, the other increases. If one decreases, the other decreases. So they're going in a direct proportion. One's going up, the other goes up. One's going down, the other goes down. So y equals a times x is one version of this here. We can also say that x is equal to a times y, or we can solve this for a and say that a is equal to y over x. Or we can also say that a is equal to x over y. Those are the same equation, they are the same expression, it's just we're flipping the x and y values. Now that will change the value of a, it's just going to be from a to 1 over a, but that's still just a constant term. Our other one that we have is inverse variation. Inverse variation is given to us by y equals a over x. We could also say that x is equal to a over y, or y times x, or x times y is equal to a. And all we're doing is just manipulating this equation to see the different forms or different ways it can be written. And a is just a constant term, it's just a number. Questions on this here? So the first thing we're going to do with this here is just identify, based off the equation given, is it direct, inverse, or neither. So the first one we have is x times y equals 5. Which do we think it is? Direct, inverse, or neither? Inverse. Now there's several ways we can get to the fact that this is inverse. One of them is noticing that if we get the constant term by itself, y equals a over x, multiply both sides by x, we get x times y equals a, x times y equals a number. Now another way we can look at it, x times y equals 5. I can get y by itself. To do that, we would divide both sides by x. Here, the x divided by x would simplify, leaving us with y equals 5 over x. This is inverse variation, y equals a over x, inverse. Another is we can plug numbers in and see is one increasing and the other decreasing. Different ways to get to the same answer. Questions on A? Let's look at B. Y equals x minus 4. Well, this doesn't look like direct, because direct comes in the form of y equals a times x, or y over x equals a. And it doesn't look like inverse either, because what's the big difference that this has that direct and inverse don't have? There's one big thing that it does, this equation has, that our general forms of direct and inverse variation don't have. Subtraction. Inverse and direct variation do not have addition or subtraction. We're talking about multiplying by the same amount, the same ratio. So this has to be neither. Addition and subtraction is going to be the biggest indication that it's going to be neither. It's not inverse or direct variation, because it does not have to be one or the other. Not every equation is going to fall into direct or inverse variation. There's a lot of equations that do not follow either one of these here. There's actually more equations or more setups that don't follow direct or inverse variation than there are that direct and inverse. Quadratics, cubics, quartics, those are not direct or inverse. Let's look at C. Y over 2 equals x. Would this be direct or inverse? It is going to be direct. Well, one of the hints is we had already one inverse and one neither. But if we look at this here, y over 2 equals x, I could actually rewrite this as 1/2 y equals x. Our y equals a times x equals a times y. A in our case is just 1/2. Or I can get y by itself. We can multiply both sides by 2. Because if I multiply both sides by 2, 2 times 1/2 is 1, so we do get y by itself. On the right-hand side, x times 2 is 2x, y equals a times x. This indeed would be direct. Another way we can look at the equations, especially direct, y equals a times x equals a times y. X and y are both in the top of the fraction. They're not in the bottom, they're on opposite sides, so it has to be direct. If the variables are on opposite sides, one's on top, one's on bottom, y equals a over x equals a over y, it's going to be inverse. All right. Any questions on any of this so far? Let's look at number 1. 6x equals y. Direct, inverse, neither. Direct, because it is our y equals a times x. Number 2, x times y equals negative 0.25. This would be inverse. X times y is equal to a. Y plus x equals 10. Would be neither. What's the big indication that this is going to be neither? Addition. Addition, subtraction, we won't have exponents for inverse and direct variation because inverse and direct variation is a constant ratio that's being multiplied, or a constant amount that we're multiplying each term by. We'll go on and finish this out. Let's do the last 3. X times y equals 17. Inverse. B, y equals x plus 29. Neither. Y over 10 equals x. Would be. It's going to be direct, because we can think of it as 1/10 times y equals x. Variables are on opposite sides. Both of them are in the top of the fraction. They're in the numerator, so it has to be direct. If they're on opposite sides, one's on top, one's on bottom, it's inverse. If they're on the same side and being divided, it's direct. If they're on the same side and being multiplied, it's inverse. Questions on being able to determine, based off the equation, if it's direct, inverse, or neither. Well, we're still going to do that with direct, inverse, or neither. We're going to test it with a given set of numbers. Now, the value A has to be the same. That rate, that amount has to be the same across all the terms. Now, direct variation, we'll look at it first with A. So direct variation, y is equal to a times x. That's the general form we got. Now we can solve it for a, divide both sides by x, and it tells us y over x is equal to a. And that amount, that value of a, should be the same across every single term. So if we look at this here, and we take our first values of x and y, 2 and negative 12, and plug them into this equation, so negative 12 over 2, the y value divided by its x value, that ordered pair, will give us a value. Now, negative 12 divided by 2 is negative 6. So if this is direct variation, I suspect we should have negative 6 as the value for a for all of them. And if it is, then it is direct variation. So we would look at the next one, which is negative 6 divided by 4. Negative 6 divided by 4 is negative 1.5. Are those the same? No. So we know it is not direct variation, because that value of a has to be the same across every term. Questions on this here? Okay, I'm going to erase it so that we can have, you can write it just below it, because our second option is inverse. And the general form for inverse variation is y is equal to a divided by x. Or x times y is equal to a, because if we solve for a, get a by itself, we multiply both sides by x and get this here. And so what we can do is take our x and y values, so 2 and negative 12, and multiply them together. 2 times negative 12 is negative 24. Then we can move on to our next set, 4 and negative 6. 4 times negative 6 is negative 24. Now we can do the same thing with 6 and negative 4. Well, that's still going to give us negative 24. And lastly, 8 times negative 3 is also negative 24. Now, since the value of a, it is the same across all of them, we know that this has to be inverse variation. That value of a has to be the same across all of them. And you have to have that same amount, that same value of a, for it to be an inverse variation. Questions on this here? Now that also tells us what the equation is, because y is equal to a divided by x. It told us the value of a is negative 24. So the actual inverse variation equation for this is y equals negative 24 over x. Now this problem here did not ask us to find the equation. It just asked us to tell whether x and y are direct, inverse, or neither. And here it would indeed be inverse. Now just because direct didn't work doesn't necessarily mean inverse will, because we do have the third option of neither being the case. Questions on A? Because what we're doing is using the general form to see, is the value of a between each of these numbers the same? If it is, it connects to that variation. If it doesn't, it's not. If we look at B, we have 1, 2, 3, 4 for x, and the corresponding y values are 2, 4, 8, 16. So we could start with direct variation. Y over x equals a to compare the two values. So the first thing we can do is 2 divided by 1, which is 2. Our next one would be 4 divided by 2, which is also 2, yes? So can we say this is direct variation? Well, let's make sure and check the rest of them. 8 divided by 3 is 2.6 repeated. And 16 divided by 4 is 4. So even though the first two are the exact same, it didn't make a difference, or really matter, because the third and fourth one did not have that same value of a. So that means it's not direct variation. I would make sure to check all the values, because there are some, not normally, but it could be the case that the first three worked and the fourth one doesn't. Or it could be the case that the first four work, but the fifth one doesn't. Does that make sense? That is always the issue in mathematics, because when we're trying to prove something or show something's true, we have to show it for all cases or prove it in a general case so that everything does work. Because even if we show it like this here, we showed that it works, it showed for all possible cases listed, it works. But if we're showing it for every number, I have to either A, show it in a general case that it works, using variables that stand for all real numbers, or I have to show it for every possible case, for every possible number that could work for that. That is not always the case, because there could always be one more or one that we haven't tried yet that doesn't work, which proves it wrong, even if we've proven it for 2 billion cases. All right, let's check inverse. Inverse is x times y equals a. 1 times 2 is 2. 2 times 4 is 8. They're not both the same, so we're done. We don't even have to check the rest, because again, those values of a have to be the same. If they are not the same, it doesn't work. So that means this one is what? Neither. Interestingly enough, you don't necessarily need this. This is exponential. Y equals 2 to the x would be the equation for this here. Questions on this here? You ready for the next one? Yeah. So the 2 to the x isn't necessary. It's not needed. I'm just telling you what the function actually is. So I would look at the numbers also, because they're going to give us a hint at what it might be. Because direct variation, as one increases, the other increases. Inverse, as one increases, the other decreases. They go in opposite directions. I would not think of it in terms of actual increasing value. Think of it in terms of approaching or going away from 0. Are they both approaching 0? Are they both going away from 0? Is one approaching and one going away? Because here, if we look at this here, so x is -4, -3, -2, -1. So those values are going towards 0. 20, 15, 10, 5. Those numbers are approaching 0. So they're both approaching 0. So that means they're both going in the same direction. So there's a good chance that this could be direct. And the test for direct is our y over x is equal to a, this constant amount. (20) divided by -4 is -5. 15 divided by -3 is -5. 10 divided by -2, -5, and 5 divided by -1 is, so it is indeed direct. And the reason I say think of it in terms of 0, is it approaching 0, is it going away from 0, is because just increasing or decreasing, especially in terms of negatives, really throws this off. Because -4, -3, that is increasing. If we talk about negatives, that is getting bigger from term to term. 20, 15, 10, 5, that is getting smaller. So just in terms of signs, it looks like they're going in opposite direction, this inverse. Now we're actually, approaching from the left-hand side, it's going down, but because our value of A is negative, it makes it look like we have this here. But they're both going towards 0. They're going in the same direction. Well, let's actually back up and look at this. Number 2, or number A, letter A, 2, 4, 6, 8. That is going away from 0. If we look at the other one, negative 12, negative 6, negative 4, negative 3, it's going towards 0. One's going away, one's going towards. That's opposite. So it is indeed inverse, and we can prove it. We showed that it was. Do we kind of see that there? Yeah. It's easier to see it as approaching or going away from 0 than it is to try to think of it in terms of signs and how that works. Number 5. Our x values are 1, 2, 3, 4. Our y values are 60, 30, 20, 15. Default, we can just try both. As we could try direct and do our y over x is equal to A. So 60 divided by 1 is 60. 30 divided by 2 is 15. They're not the same, so we are done. Inverse. 1 times 60 is 60. 2 times 30 is, well, 60. 3 times 20 is 60, and 4 times 15 is 60 telling us these are inverses. They're inverses of each other. Questions on this here? All right. I think we have 2 more of these, and then we have the last type. So if we look at this first one here, our x values are 2, 3, 4, 6. Our corresponding y values are negative 6, negative 4, negative 3, negative 2. We're thinking inverse or direct? Inverse. Because our x values are going away from 0, our y values are going towards 0. So there's a good chance that this is inverse. And our inverse is our x times y is equal to A. I'd just start off with 2 times negative 6, which is negative 12. Well, 3 times 4 is 12, so 3 times negative 4 would be negative 12. Well, if you notice the next one, 4 times negative 3 is just the flip, and then lastly 6 times negative 2. So they are indeed inverses. Questions on this here? So we don't even have to check direct, because if it is inverse, it's not direct. If it's direct, it's not inverse. If it's one, it's not going to be the other. X on B, the last one, 2, 4, 6, 8 are our x, and their corresponding y values, 24, 16, 12, 4. If this is going to be one of them, it should possibly be what? Inverse. So we can check our x times y equals A. Which is 48. 4 times 16. Well, 16 times 2 is 32. Times 2 is 64. So those are not inverses. Now we can check direct. Now, that is a good question. Could we do x over y? Yes. Because x over y would be 2 over 24, which is 1/12. Our next one is 4 over 16, which is 1/4. Those are not the same, so it's not direct. Now, yes, if we did y over x instead, we would get 24 over 2, which is 12. 16 over 4 is 4. Still not the same. We still get the constant ratio, that constant amount. It's just the reciprocal of the amount we would have gotten otherwise. Still the same amount, it's just the flip of it. Questions on this here? Last thing we're covering with this here. Write the inverse variation equation. So the variables x and y vary inversely. Y is equal to 8 over x. And y is 4 when x is 3. Write an equation that relates x and y, then find y when x is equal to -2. So it wants us to find two things. One, we need the equation, and two, we need to know y when x is -2. Now to do that, we need the value of a, because once I have the value of a, I will have the equation. And once I have the equation, I can find that value. Now there's two main ways to find it. They're essentially the same thing. I'm going to take the equation y equals a over x. I'm going to replace the y with 4 and the x with 3, telling us that 4 is equal to a over 3. Now I just need to solve for the value of a, yes? So the first thing we can do is multiply both sides by 3. Now on the right-hand side, this is really 3 over 1, so our 3 and a would multiply, giving us 3a. On bottom, we'd have our 3 times 1, which is 3, telling us that we have 3a divided by 3. Well, 3 divided by 3 is 1, so 3a over 3 is just a. That cancel out. Now, for the most part, I will write this out like this every so often, but really what we could have done is what? Just they cancel each other out. On the other side, we have 3 times 4, which is 12. It's telling me that the value of a is 12. So the first part of our answer, y is equal to 12 over x. You do have to have that. There will be questions like this on the homework. You do need the equation as part of your answer. Just finding a doesn't answer it. We need it put back in. Y equals 12 over x. Questions on how we found the value of a with this part here? Now, yes, I did say there was another way we can find a. Because y equals a over x was one of the equations we used for inverse, yes? What was the other equation? X times y equals a, yes? That's our other equation with inverse variation we use. Y equals a over x is the equation we want to have as part of our answer. But we can still use this to find a. Because they told us x is 3 when y is 4, yes? 3 times 4 is? Oh wait, isn't that what we did anyways? It's just another way to find a. For finding a, do we like method 1 or method 2 better? 2 is a little bit nicer. We just plug it in and we have our value, yes? We'll do that one from now on. Now the last part is to find the value of y when what? X is -2, yes? Well, we know the equation, y equals 12 over x. So in this case, it'd be 12 over -2, yes? And 12 divided by -2 is? So the second part of our answer is y is -6. So y equals 12 over x, and y equals -6. That's it. Questions on this here? The variables x and y vary inversely, and y is equal to 8 when x is equal to 4. Write an equation that relates x and y, then find y when x is equal to negative 16. Well, we need to find our equation for y equals a over x, and then we need to find our value of y. In order to do any of that, we need to find the value of a, because if I find a, I get our equation, which is half our answer. And once I have the equation, I can find any value of y for a corresponding x. Now they told us the value of x and y are 4 and 8, so we can plug it in. 4 times 8 is equal to a, telling us that the value of a is 32. Now that is part of our answer, but that's not specifically the first part of the answer that they want. The first part of the answer that they want is the equation, y is equal to 32 over x. Questions on this here? Now, especially with the ACT, you're going to have to take it in the spring. We have one coming up soon. Do pay attention to what they're asking, because the ACT loves switching or kind of some misdirection in the answer, because sometimes they'll ask for a specific length or a specific value, but you need the change, not what it actually was. They like being tricky for no reason. And the last thing we need to do is to find the value of y when x is negative 16. So we're going to take our y equals 32 over x and replace the value of x with negative 16, giving us y equals 32 over negative 16. And 32 divided by negative 16 is negative 2. Questions on this here? Are you ready for the next one? You're good. We'll look at one more. 6, 7, or 8. Which one do we want to look at? 8. The variables x and y vary inversely. Find the equation, and then find the value of y when x is 2. So, first thing we need to do is find our equation. Y is equal to a over x. Now to find the a, we know that x times y is equal to a. So for us here, a is equal to 1/2 times 16. And 1/2 times 16 is 8. So our equation is y is equal to 8 over x. Then we need to find the value of y when x is 2. And they will do this on the homework questions. Be set up just like this here. They'll give you the x and y, they vary inversely. And the value you're looking for is in the question. Well, here, 8 divided by 2 is 4. So y is equal to 4, and y equals 8 over x. Now, if the value of y, we're solving for y, does not divide nicely, does not divide evenly, you can leave it as a fraction. Questions on any of this here? Questions on anything we've done so far? And That's it.